Each year, as a society, we produce more than 100 billion garments. We're talking about 13 garments per person per year. Those garments are actually worn between 7 and 10 times before they're thrown away. So the issue then is that when they're in the bin, on average, 92 billion of those garments will go to landfill or incineration. So as a society, we consume a lot, we use little, and the issue then is that we don't have the solutions to actually treat that waste. So I'm Marco Bertone, CEO and co-founder of Syntetica. Syntetica is really building the future of textiles. Nylon is the fibre which is most blended in the world. We're talking about close to 10 million tons of nylon waste each year. In 10 years from now, I want to have built a model and a company which shows that a century of fossil fuels can be replaced with a genuinely scalable circular technology.
All right, a couple of things before we start. First, I'm building this show solo. Week after week, I'm bringing you the best founders and investors in European climate tech. So if you want to support this mission, please give us a follow and a 5-star review on Apple Podcasts and Spotify. It's free, but it really, really helps the show. And second, thank you to Maxime, Bruce, and Hexa for letting us record this interview in their studio. Maxime, thank you again for your support. You've just announced a large $30 million round, brings total funding to $40 million. We'll talk about that in a minute. But before we get there, we need to kick this off, I guess, with the overall picture. Can you take me from first principle? Why do we have such a big textile waste problem in the first place?
It's a good question. I mean, the why, maybe we start by laying out what is the actual problem. So each year, as a society, we produce more than 100 billion garments. On average...
100 billion?
100 billion garments, yeah. So obviously with the 7, 8 billion people we are in the world, we're talking about 13 garments per person per year. You then have a situation where those garments are actually worn on average between 7 and 10 times ever before they're thrown away. So as a society, we consume a lot, we use little, and the issue then, which we'll look at after maybe, is that we don't have then the solutions to actually treat that waste. But I think the start is really also the fact that we are consuming significantly more today than we did even just 10, 15 years ago. And when you look at, what is the driving force behind that, we really see the rise of, fast fashion, a business model like Zara's, which is frankly revolutionary, where they can design and launch a garment within 2 weeks. Shein now does it in 7 to 10 days. And what that does is it gives, rise to something where every week, every 2 weeks, you walk into a Zara store and it's a different store, which is obviously extremely cool from a consumer perspective, but which is, terrible from a consumption perspective when you don't have a solution for the actual waste. And yeah.
So is that more of a consumer behavior problem that we have here?
It's difficult. It's kind of chicken and egg, isn't it? I think it's clear that we obviously, we're sitting in a society where it's driven by the innovation of the business model, which, for example, these fast fashion companies brought around. And then, of course, it, drives consumer behavior, which then drives further production. So, it's sort of one drives the other. You equally have that model, but you also have models like, a company more like Uniqlo, which is actually, all about producing extremely high quality, high volume basics, which is a different form, obviously, of fashion. But if we sort of take it then a step back so we buy 13 garments a year, we use them 7 to 10 times, and then we throw them in the bin. So the issue then is that when they're in the bin, on average, 92 billion of those garments will go to landfill or incineration each year. And so that is the cycle when you go, down the funnel. Not even a very big funnel. It's like
Not
a
a
very,
funnel, really.
yeah, it's not a funnel at all, of what happens to a garment. Yeah.
Okay, well, and obviously, I think at this stage, after I think this is gonna be episode 105 or something. I don't
Okay.
believe in consumer behavior change for sustainability anymore. So, unless we ban those fast fashion companies and make the price of garment the price what it should look like, I don't think it will change so fast. But so walk me through it. So I buy a new garment, I throw it away in the bin. What happens next? Because I would have thought that someone would take it and recycle it or do something with it or, upcycle it, whatever that is, right? But I would have thought that someone did something with it.
Yeah. So today, I mean, a part of it. So let's talk about that first 92%. So the first 92%, if we sort of take a step back, what is a garment? A garment is a combination of fabrics, dyes, and often multiple materials. So to be fair, right now I'm wearing pretty mono material, like a cotton t-shirt and a linen trouser. But you have, nylon elastane combinations. You have polyester and cotton in t-shirts. Garments are all about performance, feel, fashion, and aesthetic. And that's what drives actually, the revenues of different brands and obviously, engagement as consumers. The issue when you have multiple fabrics, colors, coatings, etc., is that it's complex. We're good as a society at recycling pure plastic bottles, monomaterial, monocolor, you melt it down. When you have that complexity, there aren't historically the systems in place to separate that. So when you throw it in the bin, no one has the technology behind that to separate out the materials. So it gets picked up either by the state or by charities, who then sort of subcontract that out to waste collectors and sorters, which have, big hubs actually, in Belgium, Germany, some in France as well. And then what they will do is effectively, look at what's the quality, how, destroyed is this garment, and where can it sell? And today, the collection and, sorting industry is really geared around resale, which makes sense as well. There's really a pyramid of what we should do. There's reuse, resell, and recycle. So it makes sense that they want to reuse, but also from a resale perspective because they get the biggest return on investment. So they'll resell to the European market. And then what they'll do is they'll resell to the African continent, to Asia, and it will then effectively get flowed to all of those countries. And it's actually a very good documentary by the French journalist Mathieu Stéphanie on this, where he puts a tracker in a bin and you sort of track where the garment goes. And the issue is that when, a huge amount of more than 50% gets exported, what gets exported is really the low of the low. Nobody in Europe supposedly wants to wear this. And so again, it flows out. And then from there, the reality is it will get discarded. And when you don't have, the public systems around mass waste collection, sorting and all of this, effectively you then find yourself with these crazy images of the desert in Chile or the Sahara Desert where you just have, streams of waste. And obviously that's just an extreme visual representation of what is a much more systematic problem, which is a global one. And so, yeah, it's a complex problem, but which also fundamentally comes from a mismatch of there's no technology capable today of actually recycling the complexity of that waste. Yeah.
You haven't talked about it yet, but as a percentage of global emissions, where do we stay? Like, where are we with fashion?
We're talking about, more than 7%. We're talking about one of the biggest, on average, you have this sort of range between 7 and 10%. We're talking about one of the biggest drivers of pollution, of sort of global emissions in the world. And, more than shipping, more than a bunch of industries which you associate with being high carbon emission.
Yeah, flying is 2%, for example.
Exactly.
So, yeah.
Exactly.
Okay. Yeah, and that's also the part that, I mean, this episode makes me even more anxious about fashion so far, at least, because you're basically telling me people buy crap products that they don't use for long, that they don't recycle. And by the way, it travels all over the world 5 times before it gets anywhere. So it's quite a depressing situation, to be honest. Putting this aside, and before we talk about the technology, do you believe that fashion will come back to something more sustainable in terms of like buying higher quality materials, higher quality garments, maybe that are more expensive but that last longer? Is that something that you see as a trend?
100%. And to be very clear, like I'm a founder, I'm a hopeful, I'm obviously
Mhm.
extremely positive on the industry. And also, from my perspective, the fashion industry is and it's not just fashion, it's textiles more broadly, but it's an incredible industry for expression, for creativity, for art. The reality is, why do we consume 7 to 10 garments per year? Sorry, why do we only wear something 7 to 10 times or consume 13 garments per year? It's because we also want to express ourselves. It's, for me, the reason behind the problem is quite a beautiful reason, is that we love to, try new things. We get into new sports, so we buy all of the gear, or, it's part of what also makes humans human, that we have this problem. So for me, the industry behind that is an extremely skilled, crafty industry. There's a global production cycle behind it. I've been to factories in Sri Lanka. I've been to, where you actually see what goes into making a garment, and there is artistry even at the biggest mass produced level, because it is an art to produce that many garments of such high quality, delivered on time, across the world. So for me, the pain behind it is one where, as a society, we need to just take a bit more of a systematic effort, politically, technologically, to actually fix. But the industry itself serves something which is beautiful, and deeply human. Yeah.
Yeah, and yeah, to your point, I think giving access to lots of people to fashion is also a great thing. Like not having prices that are too high. The thing is like it has to be at some point reasonable. Well, at least on my perspective, I think fast fashion is something that's terrible for anyone because it just pushes more people to buy more stuff all the time. But hey, what do I know? That's my opinion. Um, when we think about this sorting and kind of first layer and the recycling part, is that something that's well all today, so like it works out really well, like because like I would assume that for you, and we'll talk about your technology just after, but like you have to get textile from somewhere.
Yeah.
So is that something that you have to build, or is that something that's already built and well managed?
So that's actually the biggest barrier today, to scaling our technology. There's actually So today there's a very linear value chain which begins with petrol-based, raw materials, and then produces, yarn, fabric, garments, goes to the customer. The two pieces of the missing, circular value chain are the collection and sorting, and then the actual recycling. So one is a technological problem, and the other is more of a logistical, technical, a mix of those problems, because collecting is fine, sorting. So how do we actually sort? We've just spoken about how complex it is to, um, all of the different materials involved. We recycle nylon. There's other players that recycle polyester, players that recycle cotton. Someone needs to physically identify which fiber is which and send that. The sorting industry is today geared towards humans that pick garments up and say, this is good quality and a t-shirt. This is bad quality, and a short. So we need to sort of switch that into much more of this is bad quality in polyester, and so it goes there. And that's where, there's a bunch of new technologies arising around infrared, Raman spectroscopy that we're looking at a lot. We use, on a daily basis to help identify fibers, because then you can get quite deep in complexity in terms of what contaminants can you take, what's the percentage of that material. But there is that fundamental, so there's an identification problem, and then there's a sorting problem, which is obviously, we can talk a little bit about the economics after, but the moment a person touches a garment with their hands and puts it to the left or to the right, the costs involved of recycling become very complex. And so there's, a great number of companies now trying to automate sorting. Definitely, in China, they're way more advanced on this. They're processing 100,000 tons of waste per year, in a much more efficient way. But there's also a lot happening in Europe, and Syntetica itself is actually, the more we see the problem, the more we take a step back and sort of, go into it more and more, especially around, building data models to understand, what contaminants cause what, and really driving into the identification of waste.
Yeah, it's almost like you would need a tag on a tag on a garment or something that basically you could scan very quickly, like the Decathlon RFID, for example. Like if you had that, you could sort much faster.
Exactly. And you know what? We're actually, every brand that we work with is looking at this. What is the unified system, which is the most scalable for the years to come? And definitely a simple tag is gonna, sort that out. So that's a key one. Yeah.
Yeah, because I could imagine from the look and feel of a product, it's probably hard to say what it's composed of.
Yeah, yeah. I mean, you can get quite good at it, but honestly, it's extremely difficult. And you have the tag in a garment, which you need to sort of try and find. It says one material, another. If you have that scan and it can tell you, 83% nylon, 70% elastane, great, that goes directly there. Yeah.
And so, in a world where that happens and we become good at identifying what's into a garment, how would you then split the material? So, in other words, if it's majority nylon, does it goes to Syntetica? But then, what do we do with the rest?
Yeah. So in terms of the materials used, obviously polyester and cotton today represent close to 70 to 80% of the actual overall mix. Um, they come in purer, so you often have 100% polyester, 100% cotton, and then you have a mix which is polycotton. So they're obviously larger volume and relatively cleaner feedstocks as well. When we started Syntetica, we wanted to operate around the greatest complexity, the biggest unresolved pain point that we saw. And so we focused on nylon, which is the third most used fiber in the world, and represents between 7 and 10% of the actual textile waste and sort of fashion production there. So in your idyllic, futuristic world, you aggregate waste in certain hubs, which are sort of co-built, co-funded by public-private partnerships. You have all of this sort of, technological infrastructure in place. And yeah, you absolutely have lines where the nylon goes there, the polyester goes there, the cotton goes there. And depending on the volume, you have a number of assigned partners pre-selected by the brands themselves, because that's the reality also of what's happening is the brands are choosing, that their winners and their future supply chain. And that would be amazing.
That would
Now,
be
that's
amazing.
obviously far from where we are today, but yeah, I mean, what's actually happening today in practice is that it's more a recycler like Syntetica speaks with a recycler within the polyester space, and we're like, okay, we actually have waste that we can trade here, and let's do it. Yeah.
Do you buy waste today, or is that given to you for free?
So today it's mostly free. We work, at the tons level. We do a lot of testing. Today it's almost always free. At the demo and in our full scale economics, we have a cost of waste. So on average, we expect to pay in the depending on geography, complexity, anything from $400 to $700 per ton of waste, which it involves collection, sorting, logistics, shredding, ready to go, like ready to go in the reactor. Yeah.
Okay. Um, So let's talk about the technology and what Syntetica is doing specifically. You've chosen to go after nylon, as you said, which is a smaller percentage as part of the total waste that we have. First of all, I want to understand from a value perspective if it's also as small as a percentage or if it's a high value material, but also why nylon specifically, and where do you plug in terms of like, do you have to separate the materials yourself? Is that the thing that adds value in your process, or tell me more about
Yeah,
why Synthetica needs to exist in the first place.
yeah. So nylon is the third most used fiber in the world. It's about 3 times more expensive than polyester, 2 times more expensive than cotton. So as a market, we're talking about, $45 billion as a market when you include elastane as well, which is another one of our products. Nylon is characterized by complexity. So there's 2 main types of nylon, nylon 6 and nylon 66. There's one type of cotton, there's one type of polyester. So um, nylon 6 is more the fast fashion, slightly, you know, less heat resistant nylon. Nylon 66 is, you build airplane tires, cords from there. You build airbags from nylon 66, or, a brand like Lululemon uses nylon 66 because they're extremely committed to high quality. So that sort of nylon on average is going to be a more technical material, but within that you have a sub-split.
Mm.
The issue with that is that we're talking about a 50-50 split, which adds complexity. The other complexity with nylon is that nylon is the fiber which is most blended in the world. So we're talking about close to 10 million tons of nylon waste each year. 70%, at least 70%, is nylon blended with another material. Nylon elastane for leggings, nylon elastane also for, lingerie, swimwear, nylon cotton for jumpers, nylon with coatings, with polyurethane coatings for your, outerwear, for your raincoat, all of this sort of stuff. So nylon is never found alone, it's never found clean, and there's multiple types. So when you look at, the waste, it's a mess. So that's why we went for it, because polyester was starting to be, there were plastic bottles which were being recycled to make t-shirts. Cotton, rather than recycling it, there was more of a movement around sustainable cotton, good practices around the actual farming of it. And nylon was really this issue where the brands we spoke with said, we have no solution. So what our technology does concretely is it deals with both of these major problems. The first is that it's the only technology today in the world which is capable of recycling both nylon 6 and 66 in the same process at the same time. And the second is that it recycles nylon when it's blended with any other material. Cotton, polyester, elastane. It's really a sniper on the nylon, leaving everything else behind in good condition so that I can go speak to one of those other recyclers and trade it. The foundation of the technology is a green chemistry, low temperature, low pressure chemical process, which is a proprietary process of ours, which we've patented, developed by my incredible co-founder, Louis, and obviously now further developed by the rest of the team.
Why is it so difficult to handle both nylon 6 and nylon 66? What makes it difficult?
Yeah, what makes it difficult is, so to break them down is not, so they're two similar but different polymers. So nylon 66 is made up of 2 monomers, which is already the building blocks of a polymer. And the issue is that when you break these chains, they mix together. So breaking down nylon 6 and 66 together, technically you could do it at 500 degrees with a load of pressure, you destroy them for sure. The issue is then how do you recover the monomer? And if you destroy them at 500 degrees with high pressure, which is sort of how historical recycling processes work, 3 monomers literally become a big gunk, a big goo, and you can't separate those out. So that's where the complexity is. It's not so much in breaking it, it's in actually recovering the material to make anything valuable of it. And that's where, Synthetica's low temperature process, low pressure process enables us to actually break the building blocks, recover them, separate it, and then build something back from it. So we're really in, often I say we're more in the separation game than in the, breaking game. We really pick and then we build again from that.
And so what comes out of the process is two fibers, I'd say. Do we call them fibers? I guess so. Nylon 6 and nylon 66 that are as good as new, that can be reused in new garment. Is that the idea?
Absolutely. So they're not fibers. They don't come in fiber form. So we go from nylon waste to a monomer. So it's a powder.
Okay.
It's really a white powder. And then from here, we will make a plastic chip, a pellet, which will then turn into yarn. So that's when the fiber is made. So we really turn that waste into this first white powder. And then at the chip level, it is as good as new. So same quality. At scale, we'll talk about the economics. But from a quality perspective, you can produce same exact materials from the start. Yeah.
Okay. So you have a few steps before it goes back into a garment in the end. You talked about the low temperature, low pressure. Initial thought process for me was to say, okay, that's a process that makes it economically viable. You're saying that's also a process that allows to actually do that without harming the materials. But I just want to talk maybe a bit about the economics of it, because I would assume that green chemistry, low temperature, low pressure means that the operating costs are quite low. How do we think about the economics of it?
Yeah. So you think about the economics, and the economics has an input waste, a processing cost, and then you have your output price, for being really simple. For starters, let's look at the input waste. So the input waste, I gave you quite a wide range of $300 to $700 per ton, $400 to $700 per ton. There's a pricing question, and then there's actually a feedstock question. So because our technology is able to work on nylon 666, on all blends, what that means is that we're actually able to unlock waste that today is unrecyclable and is inaccessible. Post-consumer waste of all types is something that we can do. Historical competitors, that focus on recycling fishing nets or focus on high pressure, high temperature processes, they actually can't even access that waste. So we're accessing waste that can't be recycled, which obviously, therefore, with less competitive pressure, you're looking at that lower sort of range of, $300-400 per ton. The 700 is really for, cleaner, very processed waste, which is obviously going to be more competitive. But that's your input cost. From there, you have a processing cost where absolutely, as you say, chemicals, energy, labor, they're basically the big sort of unit costs. Um, I'm not going to be able to go into, exactly the economics at this stage, brick by brick, but where, energy is today in the petro-sourced industry, the biggest driver of the production cost. So we can talk about this after, but the European chemical landscape is under immense pressure right now because of the cost of gas, because of the cost of oil relative to Asia, where we're seeing immense cost pressure as a consequence, and that's where today our low temperature processes which operated at 400 degrees now operate less than 150. Processes that operated under major pressure now operate under no pressure or low pressure. And so we're making huge savings on the energy front. And then we have, chemicals, which is obviously we recycle, almost all the chemicals that we use. And then actually, the labor cost for us, like with most continuous chemical processes, actually relatively low as a proportion of costs. And it's really chemicals and energy. So all of that, and if we're comparing, the petro-sourced industry and the recycled, From a petrol-sourced industry, you have a high input cost, the sort of petrol-based input, and a relatively high energy cost, or let's say a medium to high energy cost. From a recycling perspective, you have a low input cost because you're using waste, and then you need to try to find an efficiency of process accounting for, your chemicals, energy, and labor to get you at price parity, because at the end of the day, the output cost is going to be the same. Anything from 2.5 to $3 to $4 per kilo is the price of nylon from a worldwide perspective. And we need to achieve those the economics, which mean that at the full-scale facility, post ramp-up, we're selling at the same price as virgin nylon, because if we don't, the barriers to scaling this will be much stronger. And the reality is that brands are very price sensitive, but because consumers, we are very price sensitive. And so when we walk into a store, price is one of the first things that we look at. Sustainability is not, unfortunately. And so it's our responsibility at Syntetica to not only solve the problem, but solve it in an extremely economical way. And with Louis and I, we really started with that idea in mind. And, at the time, Syntetica is really part of this second wave of recycling, right? There's the first wave, which had to overcome all the barriers, had to do all of, a major amount of hard work, but they also had this idea that there would be a green premium. Today, that illusion is gone. You have to build a scalable technology which achieves extremely competitive unit economics and a pricing with a virgin. And that's how we started with, yeah.
So, I mean, it's not a surprise to me, but you would confirm that basically brands are after performance and cost, and sustainability is the least of their problems, I'd say.
Sorry?
Would you confirm that basically brands are after price, performance, but then sustainability really comes last as a value prop? Or does that still resonate today when you tell them, like, this is recycled nylon?
So that wasn't the brand's perspective. That is, unfortunately, there have been a lot of consumer studies,
Yeah.
which is that when a consumer walks into a store, price, quality, color, aesthetic, feel, sustainability is one of the lower priorities when a customer walks into a store and looks at a garment. So
is that because people don't know? Like, if you were to tell people in which manner the garment was produced, do you think that would change?
yeah, I think there's definitely an education piece. I think there's a marketing piece. I think it's, of course, I actually come from marketing before starting the company. I was working a lot in marketing at Celency at the Bradbury, and to market from something negative, which is the problem that we're looking to solve, is not the best way to engage.
Yeah.
Marketing from what you can become, who you can become if you buy this product, is different. And so it's clear that it's not necessarily the best way, but I don't know if it's, a mixture of our instincts and also the society in which we were, born, grew up in, and influenced by. But in any case, what's certain is that there's many studies around that. So the value proposition of Syntetica is quite simple: same quality, same price, lower emissions. We can't communicate publicly on our lower emissions at this stage because you need a whole, life cycle assessment, which is of a certain grade to avoid greenwashing. But we have significantly lower carbon emissions made from textile waste. So it's a drop-in substitute, and that enables consumers to be able to continue using the same garment technically forever. That the same molecules, the same pair of leggings can be worn for generations with the promise of our technology.
If I were to be a bit of the devil's advocate, would I not say that this is basically encouraging people to continue with their buying behavior, which we know is not the best approach?
You could argue that. Um, you could argue that Synthetica's technology does enable. So there's two things. We have built a technology which is capable of recycling the most complex combinations. Needless to say that we make, the economics are tougher when there's 7 different materials with 12 different colors than where there's 2 or 3. So we still work a lot with brands around eco design, eco conception for recycling, where you can educate them on how much easier it is to recycle a piece when there's a few less components, etc. So we definitely still prefer a world with slightly simpler waste. Um, but yes, our objective and our customers are the brands, they are consumers, and we do want to enable a world in which everything I've said about creativity around, expression around all of this, I genuinely believe, and I do want a world in which you're able to wear a garment and someone is able to, not reuse necessarily, but at the end of its life, those molecules can be used to by another person. And there's obviously, consumption per person, but the reality is that as a population we're growing. We need something like this to enable us to actually scale. Yeah.
Yeah, of course.
But it's a fair devil's advocate.
Of course. No, but I mean, it makes a lot of sense anyway. Like, I think we have to recycle nonetheless. Um, just want to go back to what you were saying on unit economics. So you mentioned that the virgin nylon, big part of the price comes from oil and kind of, petrol-based products. So does that mean that you're very much exposed to it as a business? Because in other words, if the price goes lower, then the virgin material is going to go lower, and then that makes it more difficult for you.
Yeah, 100%. So obviously everything that's happened in Iran has increased the price of oil in the world. Specifically, actually, disproportionately impacted Asia, which is the lowest cost of nylon, where the lowest cost of nylon is. So yes, it's put upward price on pressures. The reality of, the petrol-based nylon is that petrol goes up, the cost of nylon goes up because the inputs go up. So technically, the margin shouldn't be increasing. From a recycling perspective, when oil prices go up, your input is the same. It's the waste. That the cost of that hasn't changed. Your energy cost might have increased a little bit, but it's a much smaller disproportionate cost of your overall economics, and so your spread actually increases. Equally, when we drill like crazy and the cost of oil goes down, that's when it puts a lot of pressure on recycled materials, and recycled materials lose competitiveness. Now, the reality is that our brands now are coming to us and our customers are coming to us not just for the sustainability piece, but also because we do enable them to decouple their supply chain from oil shocks, which, as we just saw obviously over the last 6 months, does have strategic planning value. And so this has now become much more of a sales argument, because we sell nylon at a fixed price for a fixed time period through offtake agreements. And that enables them to actually get, a very clear perspective on what their supply chain looks like for a period of time.
Yeah. Uh, do you think the price of oil going up is also reflected in the price of the garments, or do they eat on the margins? Because
I'm
I
not
haven't
sure.
been to Zara recently, but I don't think the price have increased.
I'm not sure. I would imagine not. I think if there's a sustained increase, they would. What I can say is that, within 2 weeks of the oil prices going up, every brand in the world had their suppliers calling them, telling them, the yarn price is going to go up because of everything that's going on, etc. When, they themselves hadn't even had the raw material shock as an input. But I'm not sure if the sort of premium has been passed on to customers yet.
Yeah, and I think anyway, I mean, I don't have it very clear in my mind, but I think anyway, like the big price of the garment that you buy in a Zara store, for example, is basically a lot of it is marketing and distribution and
Yeah.
versus raw
So
materials.
so that's another reason why, when we can talk about our path to scaling, but the path to scaling involves, by definition, selling at a premium as you scale. You don't have the economies of scale. Your cost of production is going to be higher. The way we're able to achieve that is also because nylon, or the pellet input, represents between 3 to 10% of a garment's overall cost. So a 10% premium on something worth 4% of the garment is actually not minimal, because 0.4% margin makes a difference. I can confirm for brands, but it's not going to be the biggest driver of costs.
Yeah. Uh, you talked actually about how the path to scale. Um, when does it become something that is at price parity? At which number of tons per year do you think, or per month, whatever that is, do you think that it will become very competitive with
Yeah.
virgin materials?
So you need to be building a full-scale facility, and a full-scale facility is anything from 20 to 100,000 tons per year. Obviously, you have different sizes. Some of the major established ones today in the world, both in Europe and in China, operate at 100,000 to even 500,000 tons per year. Um, but I think you can get to very competitive economics with the 20 to 50,000 ton mark. Yeah.
How much does it cost to build something like that? And also, I mean, as a follow-up question, is kind of who finances it? Because that's always the part
Yeah.
that's very difficult for a
Yeah.
company like yours.
So how much does it cost? It depends on the technology. There are significantly higher capex technologies. When I talk especially about that sort of first wave of technologies, a metric that is really interesting to follow is the cost per ton, the capex cost per
Yeah.
ton, which was, as high as, even the $5,000 to $8,000 per ton. Without going into the detail, our process allows, for a low capex approach. It allows for certain, modularity around the way that you scale. And that's a key, value proposition less from a brand perspective, but more from an investor perspective, for why, we're able to scale in a more economical way. In terms of how do you finance a facility? Well, let's say you're building your first of a kind. It costs, I don't know, $100 million. 50 to 70%, well, 50 to 60% of that can come from project financing, not more, 40 to 60%. To unlock project financing from infrastructure banks, you need supply agreements, you need offtake agreements, which are both of the same length of time, 5 to 10 years, fixed pricing, showcase a simple, stable spread over time. That spread is what your interest rate is sort of indexed to, and what your overall loan is indexed to. And then you also need a de-risked technology, which means that you've proven, the viability of unit economics at the scale before. If you're able to achieve that, you can unlock this 40 to 60% project financing. And then from there, we're then talking about the remaining, being funded with a mixture of equity, grants, ideally, your customer participations. You can get quite creative today with, potentially tax advanceables. There's many different ways to try to finance the actual piece of CapEx, but the biggest driver is, the bulk of it is driven by project financing. Yeah.
When you say the technology has to be de-risked in sort of like a TRL level, what does that mean?
I would argue 8.
8. Okay.
Yeah.
Okay.
Typically you want a demo. So for us, our full-scale facility will be ours is a continuous chemical process. And at the demo, you'd want it to be, as continuous as possible, so that you can argue that there is no technical jump needed. All you're doing is either, building more of the same lines, or increasing the size of each line or each piece of equipment, but by a factor which is considered to be, extremely safe within the chemical space, at least non-performance affecting. Yeah.
Which is your approach? Is that the first one or the
Combination of the
combination
both.
of both?
Yeah,
Okay.
exactly.
Where do you stand on that actually, in terms of like having secured the offtake agreement on one side, the supply agreement on the other? I think you've announced recently quite a large partnership, I've heard. So can you walk me through some of the progress you've done?
Yeah. So everything that we do is with this in mind, with these three pieces in mind. If you use them to guide that, they're also the driving force behind raising equity. This $30 million round has a mixture of equity, grants, as well as debt, from some of these early banks. And it's truly driven by having these bricks in place. If we start from the tech, one of the biggest challenges which players have had in the past is they did it all alone. They wanted the economics looks better when you do it alone. So, let's build big, let's be ambitious, let's take over the world. I'm a bit more pragmatic in my approach, especially driven by some of the failures that we've seen. And so this partnership with Michelin is an industrial partnership to build a factory on their sites, benefiting from, a huge amount of their engineering expertise, potential, operational support, quality, safety, logistics, all of this sort of things enables us to move faster and to de-risk our technology. So for me, this partnership is critical. And at the full scale, our ambition is also to find partners industrially as we scale. So if you're able to build a demo facility which operates in semi-continuous mode with a major partner such as Michelin, it produces commercial volumes, you've taken a major step towards that project financing step. From a supply and demand agreement, today we work with, in terms of public partnerships that we've announced, we work with companies such as Uniqlo, the Lycra company, Victoria's Secret, Itam, DIM, and we have a number of other sort of more confidential partners. One of our investors of the raise that we've just announced is Lululemon as well. And so with all of these partners, it's really about preparing for scale. So what needs to be validated? What do they need to see at the, real leadership level to, say I want to source from Syntetica for the next 10 years. And often it's a combination of price, quality, and sustainability. And so, we build different roadmaps around validating what they need at different stages. Yeah.
And the good thing is that those partners can be on both sides of the equation. I believe like you could be a supplier as well as an off-taker at the same time, because you're basically kind of, just putting back material into this circle.
100%. I mean, all of our customers have basically, they've come about from either they wanted recycled materials and it led into, us taking their waste, or they came to us for a waste problem. And obviously once we recycled it, wanted to have it back. So there's major synergies, even if the nuance of it is that it's more at the fabric and garment and yarn making level that waste is generated than at the pure, brand level. But there's a lot of power to influence. Yeah.
I was about to ask. Yeah, I think it feels like that in this industry, the brand is the one that has the power anyway.
100%. The brand is consumer facing, investor facing, regulation facing in many ways. The brand has huge amount of power to influence its supply chain partners. Where I would also say, though, is that the supply chain has huge power. So one of our other investors of this raise we've just announced is MAS Holdings. MAS Holdings is one of the biggest garment manufacturers in the world. They make garments for, Lululemon, Victoria's Secret, but also major partners such as Nike, etc. What they do there is, working with them and them taking a bet on the recycled nylon space is to expand also the offering to a huge number of other brands. So you do need partners, ambassadors sort of along the supply chain to help you really scale successfully. Yeah.
Fascinating. Look, we're getting towards the end of this episode. There's a few things I want to ask you before we close this off. The first thing is, and this is with full respect to you, what did you have to learn? Because you're a guy from marketing and you're not playing with an industrial company
Yeah.
with very difficult type of financing, very difficult chemistry. Not saying that you didn't have the skill, but probably not. It's
Yeah.
so much that you have to learn.
Yeah.
What was the hardest part?
Well, I had to learn everything. Yeah, that's for certain. I think I'm very curious by nature. I think I've always been fascinated by doing many different things, and I think you just learn so much every day if you're, able to ask the right questions and you're humble in admitting that you start from a very low level of knowledge. You can learn hugely. You can find the right people who have had certain experiences. I've been very conscious early on of surrounding myself with, the ex-founder of Northvolt is an advisor of ours, of Vercor. There's many different players around us who have seen and lived certain events to the end. And when you have someone like that around you, and you have a small problem today, or what feels like a small problem, and they can offer that sort of advice, you can learn extremely quickly. So that's been key. And then definitely the chemistry side, although for that I rely a huge amount on my co-founder Louis, our CTO Ash, and all of the technical team that we have, because my role is not going to be
Yeah, of course.
to solve any of the science problems.
Of course, but you still have to talk about it in front of customers and
Yeah,
investors
absolutely.
and whatnot.
Yeah.
No, but I'm actually very impressed by. Yeah, it's an impressive journey to where you are now. I feel like when you were talking about the financing, everything feels very clear to you, which I would argue that probably 3 years ago you had no clue about.
Well, 3 years ago we didn't even know each other. But 3 years ago I wasn't. We only met with my co-founder Louis. It was October 2023. So yeah, 3 years ago, starting a company was an idea, and today, yeah, it's true. We have a clear vision. I think you need to just then be very adaptable, because the picture changes very quickly. It's clear now, but anything can happen.
Of course. Couple of last question. The first one, and that's the last real question for this episode. But um, let's see 10 years out, Syntetica is successful. What does that look like, and what does that changes for the world?
Yeah, I think so. Syntetica today, we spent a lot of time talking about textiles and nylon. Syntetica, what we're looking to build is a platform to leverage green chemistry to change the materials of tomorrow, and that's very much the end goal. Um, there's a much bigger picture involved. Today, we know that if we scale this breakthrough technology, we'll transform the textile industry, the automotive industry. This can have a huge impact on a major part of society. But for me, much bigger than that, in 10 years from now, I want to have built a model and a company which shows that, a century of fossil fuels can be replaced with a genuinely scalable circular technology. And for me, that example to replicate into other industries by other companies or by Syntetica with new technologies has a catalytic effect. And for me, that's really what I'm looking to do and the impact that I'm looking to have on the world. And I think that's what we need as a society. I think, we're quite well, the temperature's quite nice here. But obviously last week there was a heat wave. Next week there's a heat wave. We need to have examples of scalable, pragmatic solutions for society. And I'm really confident that we're on the right path to get there.
How can we help you if anyone's listening?
How can you help me? I mean, you know, there's really different, stages. I think there's obviously the investor piece. Today we're announcing a fundraising round, and right now we don't need new capital necessarily, but it's more around Series B, C investors understanding super clearly what we need to do to get there, so that we can hit the right milestones to unlock the right capital. And then I think anyone, from the space more broadly, whether it's founders or, potential partners, I think, there's waste pieces, there's output pieces, all sorts of partnerships around that are always going to be welcome.
Are you
And
hiring?
yeah, that's a good point. Thank you very much.
What sort of roles?
Yeah, we're hiring, I think we've got like 7, 8 roles out today, and we're going to got a lot more after. We're hiring a lot in engineering right now, an engineering manager. We're hiring a bunch of different, process execution, process engineers. Where I'm hiring actually a right hand to the CEO, more as an internship position. And then we have, a number of different technician and scientific profiles. So thank you for reminding me,
Of
because
course, no.
I was like, that's a good point. Yeah.
Happy to put
Get
all
the
of
word out. Get the word out.
Of
Yeah.
course, we'll put the links in the description.
Yeah.
And then last question for you today: who should be the next person in your seat for an interview? An investor or founder in climate tech that you admire?
Oh, wow.
And it cannot be Louis, by the way. That doesn't count.
It cannot be Louis. Have you spoken with, so does it have to be climate related? Fully
Yeah,
climate related?
ideally. I mean, Syntetica is climate related to me.
Yeah, absolutely. I think, for me, I'm very close to Amin Raji from Spore Bio.
Yeah.
Whilst it's not full climate, I think what they're doing is inspirational, and I would love to listen to him speak for an hour.
Yeah, and I think they're on the rise. They're the hot startup out there. Everybody talks
Exactly.
about them.
Exactly.
Cool. Well, Marco, thank you so much. Listeners, if you like this episode and if you like the show, don't forget to like, comment, and subscribe if you're on YouTube, or to give us a follow and a 5-star review on Apple Podcasts and Spotify. Marco, thank you.
Thank you. Thanks so much for having me.